All right, let's get started with Unit 8, Lesson 17. So we are going to be focusing on mathematical practices. Pretty much what we're going to do is you guys are going to solve some real world problems using all those awesome math skills you've been learning. So let's get started. Okay, so math in aquariums. A goldfish bowl is a small aquarium. Other aquariums, like those found in museums, can be enormous and have computer monitored and controlled life support systems. So, many home aquariums are made of glass or acrylic and are shaped like rectangular prisms. A sketch of Naomi's home aquarium is shown to the right. Use the sketch to solve problems 1 and 2. Okay, so for number 1, which faces of Naomi's aquarium, the top and the bottom, the sides, or the front and back, have the greatest perimeter? Okay, so we're going to write our little formula up here. So perimeter equals length plus width. You know it's super hard for me to write on here, so I'm just going to write 2, comma, L plus W. Okay, so that's 2 lengths plus 2 widths equals perimeter. So, let's see, the top and the bottom. So let's look at the top and the bottom. The top, so let's find the perimeter of the top first. So that would be 15 plus, okay, so we'll just do the times 2. Sorry guys, I'm probably confusing you. This is supposed to be a parentheses. So the perimeter of the top is 15 plus 30 for the length and the width of the top and the bottom. Because the top, it's 15 inches long, 30 inches wide, and that would give us 90 inches. But we don't want to write 90. Well, we can write 90. But that's just for the top, and we need to do the top and the bottom. So we're going to multiply that by 2, and we're going to get a total of 180 inches. So we found the perimeter of the top and the bottom, and now we need to find the perimeter for the sides. So we'll just do the same thing. It would be, so our formula would start out, our equation would start out 2 times, then the sides are 15 and 18 inches, so 15 plus 18, excuse my horrible handwriting, I'm so sorry you guys, 15 plus 18, and then that equals 66, and then we multiply that by 2 to get our grand total of 132 inches. We can already see that, you know, that's probably not going to be our winner because the front and the top and the bottom have a grand total of 180 inches. So let's find the front and the back. So we have 2 times, let's see, 30 and 18. 30 plus 18, plus 18. Okay, and that is 96. Uh-oh, I think we have a winner. So then we multiply that by 2 so that we can add the back onto it, and we get a grand total of 192 inches, and that's our winner. So, under number 1, just write front and back, because the front and the back have the greatest perimeter. I'm not going to write it just because you know it would take me twice as long. Okay, so for number 2, use a formula and find the area of each of the following faces. So, the top and the bottom. We're going to find the area. So, we already know that we're going to use the same equation. So, area equals length times width. Okay, so the top and the bottom. So we would do, I'm not going to write out the equation, the numbers, but I want you guys to write it out in your SAP, and I will look and check. So for the top and the bottom, the two numbers that we're going to multiply are 15 and 30. And we are going to get a grand total of 450 inches. I'm just going to put these because that is the symbol for inches. You guys can either write inches or put the symbol, but I also want to see that you wrote A equals 15 times 30 equals 40. 450, not 40. Okay, so the left side and the right side. So our area equation will be 15 times 18, and that comes to a grand total of 270 inches. And then our front and back, our equation will be A equals 30 times 18, which is 540 inches. Cool. Okay, so use the formula and find the volume of the aquarium. So for number 3, that's what we're going to do. Well, you guys already know we're going to do volume equals length times width times, that's supposed to be times, whoops, times height. Length times width times height is the volume. And so I want you guys to write it out. I'm not going to write it out, but I want you to. You're going to write volume equals 30 times 15 times 80, which comes to a grand total of 8,100 inches. It's so hard to type on here. And we're going to do cubed. Whoa, cubed, because it's volume and we're finding the area inside of something. Okay, so let's move on to the next page. Okay, so math and aquariums continued. Use the sketch of Naomi's aquarium shown below to solve problems 4 through 6. Okay, so suppose 3 inches of sand were placed in the bottom of the aquarium. Calculate the remaining volume of the aquarium. So that means we're going to do like right about here, it's all going to be covered in sand. So that means we're going to have to subtract 3 inches from our length here because 3 inches will be taken up of sand. So this will become 18 minus 3, which is 15. And what we're going to do is find the volume of that. So we're going to do, you guys remember, volume equals length times width, that's a multiplication and that's a W, times height, so sorry. And so we're going to, I want you guys to write out volume equals 15 times 15 times 30, because that's our 15, length, width, height, 30, and we get a grand total of 6,750 inches, and it is cubed because it's the volume. Okay, so let's move on. Number 5, Naomi would like to attach rubber edging along the top edges and along the bottom edges of her aquarium. Use a formula to determine the minimum length of edging Naomi would need. So, let's see. Pretty much we're just going to be finding the perimeter. So then we're going to multiply it by 2. So we're going to write out your perimeter formula. P equals L plus L plus W plus W. So we see that our length is 30, so P equals 30 plus 30, and our width is 15 plus 15 plus 15, and that equals 90. So our perimeter for, the top edge would be 90, and then we have to multiply that by 2 because we want to find the top and the bottom. So times 2 equals our grand total of 180 inches that Naomi would have to find of rubber edging to cover both of those surfaces. So, so for number 6, suppose Naomi would like to place a flat sheet of acrylic under her aquarium, with the sheet extending 1 inch beyond the edges of her aquarium in all directions. What size sheet of acrylic would she purchase? So we know that she has 30 inches for her length and 15 for her width. So she wants 1 inch more on each side. So what we would do is we would take that 30, so we already have the 30, and we're going to just add 2 inches because we're going to add 1 inch to one side and 1 inch to the other side. So we would get 32. And then we want to find this side, the width, and that's 15. If you go back up here, it's 15. So then we would take 15, and then we're going to add 1 inch to each side, so plus 2 inches, and that would equal 17 inches. So she needs to purchase a acrylic the size of 17 inches by, that times just, it means by 32 inches, and she will have a piece of acrylic that sticks out 1 inch longer than her aquarium. So for number 7, I want you guys to try to solve this on your own. So, try to solve it, and check with me tomorrow if you can't figure it out. And yeah, I will see you guys in class.